So here we have the LeetCode problem valid square, and it says given the coordinates of 4 points in 2D space, return true if the 4 points construct a square. The coordinate of the points represented by x of I, y of I. The inputs not given in any order. So valid square has 4 sides with positive length and 4 equal angles. So I'm going to try to show you what I consider to be a geometry-based kind of clever way of solving this problem. So what the problem is saying is that we have a hypothetical plane like this, and we have 4 points in it, like so. And we find ourselves in the need of determining if these points form a square, because any kind of misplacement can represent a different thing entirely. So how can we figure out if it's a square? Well, quite simply, if we iterate through these points and we find out all the distances between them, like this distance, this distance, this distance, then for the other point, this distance, and so on and so forth. At the end of the traversal, and the idea is that we're going to put all these distances, this one, etc. We're going to place them in a set. And once we do that, the resulting size of the set should be a number of 2, because for a valid square, we can only have 2 valid distances. That is, the distance of a side like A or B, it should be the same, and the distance here of the hypotenuse, and no more. Any difference in that size of the set would mean that we don't have a valid square, quite simply. So how do we go about solving this problem? Here we have, like the statement says, the points separated, and each point has an x of I and a y of I. So the first thing, I think, to make it a little simpler to traverse would be to place all of these points in an array of points. So it would be quite simply like this. Then, just for clarity's sake, let's use this variable for the size, which is always going to be size 4. And then what else we need? We need the set that I was alluding to before. Let's call it distance set. And as you can see, it's of double type, because a distance between 2 points is not necessarily going to be an integer. It can contain fractional values. So let's stick it to be a double. And then we're just going to make the traversal among points, among all the available possible points. Like so. I plus 1, so that there's less potential for overlapping. And one of the first essential checks that we're going to perform here is, in order to minimize the potential overlap, I'm going to say if I is equal to j, I'm just going to continue. Next, we're going to calculate the distance between 2 points, between the 2 available points that we're currently iterating. Let's store it in a current distance variable. And we're going to write this function in a moment. So we say points of I and points of j. Now, like I said, there are two possible scenarios. The first one is that the current distance is a valid one. That means the current distance is greater than 0, in which case we're going to store the distance in a set. And the other case is if the distance isn't greater than 0, which means is a 0, it will mean that we don't have a valid square. And we don't have a valid square because distance of 0 represents an overlapping of points. And that's basically because we only have 4 points available. That means we have an invalid square and we can just exit from the function by returning false. And once we're finished traversing the points, we can just return the size of the set, which has to be exactly equal to 2. Otherwise, we don't have a valid square. And so let's write our distance function, which will return the double. And it takes as parameters P1 and P2, which is the 2 points that we're going to analyze. And as you know, the geometrical function to calculate the distance between 2 points is the square root of the distances between the squares of the 2 points. So that translates to square root of distance between the two x's. So the first x will be represented by P1 of 0, and the other x is P2 of 0 to the power of 2 squared. And we sum to it the other value, which is P1 of 1, which is the first y value, and P2 of 1, which is the second point y value, to the power of 2. And this should give us the geometrical distance between 2 points. And I believe this should take care of it. Let's see if it works. And oh yeah, sorry, forgot to end the statement there. And it works. Let's see if it passes all the test cases. Yeah, and it works. I don't think the complexity should be so slow, but yeah, who cares? The thing is that this is like a constant space and time problem, even with these constraints here of the nested loops, because we don't have a dynamically growing container during runtime. So yeah, that's it. I hope you liked it, and thank you very much.